So let's talk about a null hypothesis. This is a concept that you don't see a lot of times in some of the lower science classes, but as you get a little bit more advanced into college level research and beyond, you'll see a lot more of the requirement of having a null hypothesis. And a null hypothesis is kind of like a little safety net. It's a hypothesis that is essentially suggesting what is going to happen in an experiment if the thing that you are doing, your independent variable, the thing that you are actually testing, really doesn't do anything, or it actually has no effect. And so your immediate thought might be like, why would we ever ask the question, or why would we have a hypothesis that is suggesting what occurs if we didn't actually do anything? Well, it's really just a test to make sure that you know what you'd be looking for in your experiment. It didn't do anything or cause anything to shift, right? And so a lot of times when we talk about a null hypothesis, the goal is really kind of to prove it wrong, or to show that you are actually doing something in the experiment. But it does need to be discussed in much the same way that you bring back up a hypothesis during the conclusion. You'll bring back up the null hypothesis too and say, like, if I was doing the experiment and what I did didn't actually do anything, this would happen. And then if that was supported or whether it was unsupported. And so part of the trick when we are talking about this null hypothesis, which by the way is a lot of times written as H sub 0, a lot of times you will hear it stated as having no effect, or that the results will have no difference, or maybe even something along the lines of nothing will change, the status quo, right? And so like you'll see this in a lot of times when you're dealing with something like a product test or like a new drug we're trying to test to see whether it actually is going to alleviate symptoms of a disease or problems, right? It might be a situation where if you take the medication, you alleviate the symptom of pain. You don't feel any pain, you feel better, right? Your null hypothesis would be you take the medication and you still feel the pain, or nothing has changed from the start of the experiment. And so the big trick when we're dealing with the null hypothesis is you have to kind of ask yourself, what would occur in the experiment if what I was actually doing didn't actually change anything and the data was unaffected? And really one of the things that I always kind of point out when we're talking about null hypothesis is this is not an opposite hypothesis. And that's a really important thing to keep in mind, because an opposite hypothesis, or an alternative hypothesis, probably a better term for that, might be that, maybe the pain gets worse when you take the medication, right? That's not a null hypothesis because something actually changed. A null hypothesis is the hypothesis where what's going to happen in an experiment if when you do the experiment and you test your variable, nothing actually changes from it. And so just to kind of go back to what I was saying by it not being an alternative hypothesis. So sometimes you'll see like kind of the comparison of these things. So again, this here being my null hypothesis, right? And then my alternative hypothesis, or the next expected possibility. You'll sometimes see that written as H1 or HA, or, depending upon the type of experiment, you might have multiple hypotheses like an H1, H2, H3, and things like that. But none of those things are the null, right? The null hypothesis is just simply saying the thing that I was trying to do in the experiment, the thing that I was trying to test, it did not have an effect on the test. Example I could give you guys for that is like when I was doing college research for my thesis work, I did a lot of tests on trying to find different chemicals to prevent zebra mussel, which little freshwater clams, from spreading in certain waterways, right? And so I actually had a list of chemicals that I thought were potential controls for the zebra mussel. So I had a whole bunch of different hypotheses, H1s, H2s, H3s, could nitrate be the controller? Could potassium phosphate be the controller? Which one of these chemicals were actually going to slow down, prevent, or kill those zebra mussels from spreading into our systems? I had a lot of different things I could test. But in every one of those situations, I would also ask the question that if I added so many grams of potassium nitrate to this, fish tank that I was working on, if it didn't have an effect on the zebra mussels, what was going to happen in the experiment? That was the null hypothesis. So basically saying the status quo would continue. If I had 100 little clams in that fish tank and then I put the potassium nitrate in and there's still 100 little clams when it's all said and done, my potassium nitrate had no effect on the zebra mussels. And so therefore my null hypothesis would have been correct. So you always ask yourself the question, what would happen if my experimental variable, my null hypothesis, was ineffective? When you get into some higher level stuff when it comes to null hypotheses, especially when you're talking about like values of significance, you might have a situation where there will kind of be these varying values where if your data falls within a certain criteria range, then you would say that your data was supported, or a lot of times you'll hear it referred to as your data was significant. And then there's areas outside of that range that your data would no longer be considered significant. And so in those cases, because the data is insignificant or not affecting the end result of the experiment, your null hypothesis is going to exist in these areas outside of the acceptable range. And so, again, that's a little bit more complex than we're going to go into with this particular video. But if you guys have ever heard of like degrees of freedom or end tests, where they're talking about whether or not the data from the research actually met the expected criteria, null hypotheses do show up there as well. And so if it doesn't meet that criteria of significance, it would be the null hypothesis was proven. And then a lot of times in that situation, you're going to have to go back to the drawing board and maybe do another experiment, maybe alter your hypothesis or your experimental variable. But the goal of a null hypothesis is essentially to ask if I am actually changing something in the experiment by conducting the experiment. Now, just to keep in mind, most of the time, especially labs that you're going to be doing in college or high school, the null hypothesis is generally going to be disproven if you did the lab correctly. A lot of times when I'm setting up a lab, I have an expectation of something is going to happen because of our experimental variable, right? I'm still going to make my students ask the question, what would happen if the thing I'm testing doesn't actually do anything or doesn't actually affect anything? That's my null hypothesis. And so essentially, we will discuss the hypothesis and the conclusion. We'll also bring up the null hypothesis and we'll say whether or not we actually affected anything in the lab. And if we did, then we can disprove that null hypothesis and discuss the hypothesis further.